Okay, we're going to do 2.7b. This time we're talking about distance and time. And so I want you to remember rate multiplied by time is distance. So basically rate is another word for speed. Okay, and then I want to show you something over here. You have three variables. So I want to show you this little graphic here. It's a triangle. We're going to put a T inside the triangle. Okay, and here, the very top, we're going to write distance. Just like that. We're going to put rate here, and then we're going to put time right here. Okay, so now here's the important part. Rate multiplied by time will equal distance. Okay? Distance divided by time will give us our rate. Distance divided by rate will give us our time. This is kind of like a fraction bar. So essentially how this works is whichever one of these three you are looking for, cover it up. If you want distance, multiply rate times time. If you want rate, take your distance, divide it by time. If you want time, take your distance and divide it by rate. This is a really good visual anytime you have three variables. It works for force, mass, and acceleration, distance, rate, and time, like especially in science, physics, etc. Like this is really powerful. So don't hesitate to draw this little triangle. Okay, let's do some kind of remind ourselves about unit rate. So find distance traveled. Well, what do you mean? Well, if we have 80 miles per hour, see that little bar right there? That means per. Okay, this right here, it means per. And remember that per is a division. Okay, so we're talking about miles per hour. Well, all right, so I've got 80 miles and I've got 1 hour. Okay, we're wanting to know how far we can go in 3 hours. So here's 3 hours. And we want to know how many miles that is, right? So let me ask you this. 1 into 3, I can multiply by 3. So 80 times 3. When I do that, I get 240 miles. Okay. Another way to look at it is you got hours and miles. So 1, 2, 3. 1 hour is 80 miles. 2 hours is 160. 3 hours is 240. So you could do it like this. You could do it like this. Okay. Find time to travel. We have 300 miles at 75 miles per hour. So this is our rate. Okay. All right. So let's do, and by the way, here, let's talk about, before we do this one, let's go back to this equation. It says 80 miles per hour. That is your rate. Okay. So if we did rate multiplied by time equals distance, well, my rate is 80, my time is 3, and my distance, so 240 miles is my distance. Okay, so I just showed you 3 different ways. This is ultimately where you're headed, okay? But I wanted to show you how it relates back to unit rate. You can also make a table if you get stuck, but this is where we want you. Okay, so let's come over here. Find time to travel. 300 miles, that's your distance. At 75 miles per hour, that is your rate. Okay, so now let's try out this little triangle. I have to find time. Well, if I cover it up, time is distance divided by rate. So time equals distance divided by rate. And I'm using the triangle to help me this time. So time equals 300 miles, and we are going at a rate of 75 miles per hour. So my time, I'm just going to divide 300 by 75. Okay, and we will get 4. And so this will be 4 hours because we're talking about time. Now you could still make a table if you got really stuck. You could still do something like this, okay? But we really want you here, okay? And that's why I like to show you guys that. All right, let's do one more. How fast do you need to drive to cover 250 miles in 5 hours? All right, so first we found distance. Then we found time, and now we have to find the rate. Well, if I cover up my rate, it's distance divided by time. So let's write that down. Rate equals distance divided by time. So my rate is 250 miles, and we're going to do that in 5 hours. Okay, so the rate is going to be 50 miles per hour. Okay, just like that. Okay, so this is very handy for this, this, and this. And then I just wanted to remind you about unit rate. Try not to use this unless you absolutely get totally stuck. All right, here we go. Two puppies hear a whistle at the same time and begin to run towards the sound. The smaller puppy runs at 8 feet per second. Okay, so the smaller puppy is running 8 feet per second. The larger puppy is running 10 feet per second. That makes sense. Bigger puppy, it should run a little faster. Okay, fortunately, the smaller puppy has a 30-foot head start. How many seconds does it take for the larger puppy to catch up to the smaller puppy? All right, well, first of all, let's do this out. Here is my smaller puppy. Okay. And this is 30 feet. All right. Smaller puppy is going to take off from right there. Larger puppy. Larger puppy doesn't have a head start, so he's way back here. Okay. So this is my larger puppy. This is my smaller puppy. And what we're wanting to know is how many seconds does it take for the larger puppy to catch up to the smaller puppy? So basically I want to know, when do both puppies reach the same exact spot? Okay, so when does that happen? Right? So we know that distance equals rate multiplied by time. Yeah? All right. Well, let's think about it. Smaller puppy. Oh, let me get blue. Smaller puppy is going 8 feet per second. So 8 multiplied by the time. But he's got a 30-foot head start. Okay. And then larger puppy is just 10 feet per second. So just like that. And we want to know when they catch up to each other. This right here is equal. Okay, so smaller puppy equals the larger puppy. So let's write that down. We have 8t plus 30, and it's going to equal 10t. Just like that. So 10 is larger than 8. Let's move our 8. We have 30 equals 2t. We're going to divide by 2. Okay, so 15 equals t. That's our time, right? Well, what are we talking about? Seconds, minutes, hours? Well, we're talking about 15 seconds, right? 15 seconds is when these puppies will be at the same spot, right? It helps to draw a visual and then to write out what the visual represents and then make your equation. You also want to know from our triangle up top, what am I doing? Am I multiplying or am I dividing? All right, here we go. A movie director is planning a car chase scene. He wants to film a clip that is exactly 5 seconds long that shows one car catching up to another car. All right, the car in the lead will be traveling at 100 feet per second and will have a 40-foot head start. All right, well, let's draw that out. Okay, we got 40 feet head start, right? And take off, and it's going to go that direction. Yeah? Okay. And then the next car doesn't have a head start. Here. Okay. And we want to know when or how fast. Okay. So from here to here, we don't know. This is 100 feet per second, right? And we don't know how fast will the other car need. We don't know that. All right. But I do know that this time right here is 5 seconds. All right. So what do we know about distance? We know that distance is rate times time. So that's pretty easy, right? Okay. So if I'm going 100 feet per second, 100 feet per second, right? And we're going to go for 5 seconds, and we have the 40-foot head start. Okay. So this right here is my first car. Okay, that's the car in the lead. Now the car over here, we know that it's going to be going some sort of speed. This was the speed times the seconds. They had a 40-foot head start. This speed is unknown, but I know that we're doing 5 seconds. I just don't know anything else. So now I'm going to come over here and make my equation. We're going to have 100 feet per second for 5 seconds plus our 40-foot head start. And we want to know when that equals 5 seconds times whatever speed the other car is. So it looks like that. All right, so this is what we have to solve. Well, 100 times 5 is 500. And that's going to be 40. And then over here, I'm going to have 5x. Oh, that should have been p. Doesn't really matter. Okay. Well, 500 plus 40 is 540. And then over here is our 5x. Okay. And then we're going to divide by 5. Divide by 5 here, divide by 5 here. Okay. So 540 divided by 5 is going to be 108. Okay. So this car here, speed, the rate, because that's what they wanted, okay, is 108 feet per second. Okay, that's how fast this car is going. All right, again, it helps to make a little it helps to make a little diagram. Sorry, totally got sidetracked. All right, last one before you go off on your own. This question right here. This is a classic test question. This question right here. A lot of students crash and burn on this question. Okay. 2 candles are burning on a table next to each other. All right. The first candle started at 9 inches tall and is burning down. It means it's getting smaller at a rate of 3 inches per hour. Okay, so let's draw that out. We have a candle. Okay, there's our little candle. I don't know how tall it started yet. Okay, but it's going to be burning down, so it's going to get smaller. Okay, it started at 9 inches tall, so there's 9 inches, and it's going to get smaller at a rate of 3 inches every hour. So every hour, it's 3 inches shorter. 1, so 3 here, 3 here, 3 here. Okay. So the second candle started at 6 inches tall. Okay, there's our second candle. It's 6 inches tall, and it's also going to be burning down. And it's going to be burning down at a rate of 1 inch per hour. Okay, so just knowing what you know about candles. 9 inches tall, and every hour, 3 inches is gone. So I know that in 3 hours, that candle is gone. Okay, 6 inches starts at, and then 1, so every hour, it's getting smaller, okay, by 1 inch. So that means this candle would be gone in 6 hours. But that's not what they're asking us, right? It says, how long will it take for the candles to be the same height? This should have an S, right? So we want to know this. We want to know when it's equal to that. Well, we don't know how many hours. So how long is your X value? Okay. All right, so let's talk about this. We're going to start out at 9, and we're going to be subtracting 3 inches every hour. This candle here, we're starting at 6, and we're going to be taking away 1 inch every hour, just like that. You can use X, you can use T. I don't care which one you use. But we're wanting to know, when are they exact same height? Okay, so like something like this. Let's say like right here. Like, when are they the same height? Okay, that's our job. So 9 minus 3x equals 6 minus 1x. And now we're going to solve this. All right, let's talk about our x's. If I move my 3 over here using addition, okay, 3 is bigger than -1, right? So I'm going to end up with 9 over here, 6, and then 3 take away 1 is 2. So I have this. Then I want to subtract a 6. Okay, 9 minus 6 is 3. And then we have 2x. And then finally we're going to divide by 2. Okay, so 3/2 is our answer, and I talked about fractions, but this is a real world application. So we don't go around telling people 3/2 hours. We would say that is 1.5, 1.5 hours, right? That's what we would say. So even though the mathematical answer is 3/2, this is what we would tell someone if we were having a conversation. So this is a time where a decimal instead of our fraction is appropriate. Okay, well, that is all of the 2.7. You can go ahead and work on your assignment, and I'll see you in the next lesson.